Example 1, find the critical point. So we're given a function, and luckily we're given a separate piece of information to locate the stationary and singular points, because together those create the critical points. Remember, a stationary point is where the derivative equals 0, and a singular point is where the derivative does not exist. And with a graph, it was a corner, but for us, it's going to be a fraction with a denominator of 0. The key to notice is that in both of these cases, we have to look at the derivative, so that's how we begin to solve this problem. We take the given function f of x and find the derivative, which will be 3x squared minus 12. To find our stationary point where the derivative equals 0, we take our derivative of 3x squared minus 12 and set it equal to 0 and solve for x. First, you could factor out the GCF of 3, which now gives you a perfect square binomial, which is pretty easy to factor into x plus 2, x minus 2, where we still have that lead 3 we factored out. Since this is set equal to 0, we're going to use the zero product rule and set all of the terms equal to 0. Well, if you set the 3 equal to 0, that doesn't make sense, right? There's no variable to solve for, and it didn't make sense to begin with, so that didn't help us at all. But x plus 2 set equal to 0, we would solve for x by adding the opposite to both sides and get negative 2, although most of you don't even probably need to take that step. You could just take your binomial, like in this case, x minus 2, set it equal to 0, and just know that x equals 2 is the only value. So I have now found two stationary points, and I'm moving on to find my singular point. The singular point is when f prime does not exist. So I take my derivative and I look at the denominator to see if it equals 0, because that's all we have, but this doesn't really have a denominator. If anything, it's over 1. And so there's no real denominator, and there's nothing to set equal to 0, so we don't have a singular point. We're ready to answer this question. Now be careful, because we are asked to answer in coordinates, meaning xy values. So as I go to list my stationary points, and I know that x equals negative 2 and x equals positive 2, as ordered pairs I can get started, but I don't have their y values. Next, although maybe you wouldn't jump to this next, maybe you'd find the y values. In terms of the singular point, that's a nice easy answer of none, but we still need to fill something in and not leave it blank. So now I can go ahead and find the y values for x equals negative 2. Keep in mind, we're going back to the original, not the derivative, question. So when I go back to x cubed minus 12x and plug a negative 2 in for x, I get positive 16, which is the y value that pairs with negative 2. And then I basically do the same thing for my positive 2 value, plug it into the original equation to get negative 16, and I have my answer.